very much, Professor Bandhani. Hope you can hear me.
Yes, clearly and loudly. Yes.
Okay, that's great. So, thank you very much for the kind invitation, and I'm happy to be here. And also, it's very much a acknowledging to hear the introduction. And thank you so much. So, let me share my screen first. Um, hope you can see my screen now. Um,
Yes. It's A to you. Yes.
okay. So, I think this is the screen which I'm sharing. All right. So, let me start the talk today. So, we are thinking of formulating an engineering problem into research. So, let me broadly think about this one. So, we are not limiting into an engineering problem. It can be any sort of problem. Why I am saying that? Because you can't really segregate a problem into engineering now. Okay, it was there probably 50 years ago, but now it's basically multidisciplinary and interdisciplinary problems in the world. So, as engineers, you probably help with agricultural issues. You probably help with a lot of other issues, energy problems, and so on. So, you put your like inputs from the engineering sense essence to these problems. So we are trying to look into these problems in the research eye. That is the topic which we are going to talk today. So let me take you to the next slide. So before we start any sort of theoretical background of this formulation of research problems, I would like to talk about a couple of my experiences. So as you can see from these figures, so this is about the Chilla Bridge along the Putlam Road in Sri Lanka. So when I was working in Sri Lanka, so I had to do some the second years and third years in the civil engineering program. They used to go for these implant trainings. So we had to go and visit them and see how they perform in the industry. So that was one of our targets or goals in this implant training, whether they are achieving the learning outcomes of the training module. So I was visiting along the lines of this Putlam area, and I noticed this particular bridge. Okay, it was not the same picture which I have taken. At that time, it was a very dry period, and you can see most of the river bed. I noticed that this particular bridge is around the area is severely eroded, and also it has a problem of river meandering. Because of the river meandering, so it's the curvature of the rivers. So we had a lot I thought we are going to have some problems in future. um then I thought that I should be doing something to this particular case. So that was the problem which I thought. And you can see even the pile caps are exposed in this particular bridge, and you can see the damage which has happened along the lines. So the riverbed erosion, if I can take the point option, yep. So you can see the erosion, and you can see the damage which has happened to the area, and because of this river meandering. Then I thought, I should be looking at this particular case, and I just called a couple of my friends who are in the relevant authorities and asked, have you thought about this particular case and analyzing it? What would be the future impact, or how would you do the mitigational issues and to sort these things? Because you have some, important infrastructure there. So unfortunately, I couldn't hear anything from them. Then um, I faced several challenges on this one. So when I talked with my friends, they said that okay, you you can't get any data from our authorities. So, or in other words, they don't have enough data to analyze these scenarios. Then basically it's like zero support from the relevant authorities. And the funding was not that good, so it's like self-funded stuff, because I'm interested of looking at it, but I don't have a very good funding source to look at this one, and I can't do like a field study work to this particular problem. And also I had some software issues. For example, those who are working with ArcGIS and know that we have to have the full license version. Yes, we have different versions, but if you are thinking about writing a journal paper, or if you're thinking about disseminating this knowledge, so you have to have the full license version, and you have to state that. So I had several software issues. Those are the challenges, several challenges which I faced when I wanted to analyze this particular case. However, let me share the final outcome of this research. So we were able to publish a full journal paper based on this work. So we have the authors, Vindhya, Jayanga, Muru, and one of my friends from Australia, and one of my own batchmates, Dilip, another my batchmates, Amila, and so you have the DOI here. So we were able to publish the meandering of this particular river basin using remote sensing data. Now, as I told you, we faced several challenges. Now, these challenges we have overcome them using several aspects. So we used freely available, satellite data to analyze this one. And also, if you look at the other challenges, so the data, we found an alternative. I repeat that word. We found an alternative to no data challenge. Then we had limited funding, as I said. So I had a very good bunch of children, Vindhya, Jayanga, and Miru. They were happy to work voluntarily on this particular project. So that was sorted. Then we had limited funding. Again, we used the freely available satellite data. So that was sorted as well. Then we used software issues. Rather than going for ArcGIS, we use QGIS, which is the freely available version with some limitations. That's all right. So, and we were able to analyze this one. Now, these kids, now I wanted to showcase their attitude and the experience. So Vindhya is now a PhD candidate in 20 Netherlands. Jayanga is a PhD candidate now in Texas, United States. Miro is again a PhD candidate in Oulu University. Dilip, one of my batchmates, is now a PhD candidate in Stavanger, Norway. So they were working in different sectors at that time. That was in 2000, probably in year 2000 and so on, which we faced again 2019, I believe. So we faced a lot of difficulties in Sri Lanka when we worked, because of the COVID-19 and so on. But anyhow, we have obtained a very good results from this work. So you can see that we have worked, several, kilometers along the lower basin, and we have identified a set of, meandering bends in this river, and we were able to give the coordinates and the meandering length, and also the type of bend migration. So this is very important. Why? Because this will tell us the future formation of these bends. When you talk about river meandering, so that is going to be changed. It's a dynamic process. So we can forecast the futuristic views of the river meandering from this research. Now, surprisingly, after even publishing this particular work, the relevant authorities came up with a project and doing the same. So I was so happy to, that was it was not really come to me, but for someone else. But I know so it's good that even after doing the research work and publishing it in open access, so the authorities realize the importance of this particular work. So this is one of my own experience which I wanted to share, and I wanted to share another experience. So this is about paper number two, which I'm going to talk about. So a research group in Uzbekistan is working under me, and we are working basically on a health related issues, environmental issues, and agricultural issues in Uzbekistan. So they were talking about the impact of climate change with me, one of uh, our discussions, and they talked about Uzbekistan is an agricultural country where they have a lot of fruit varieties grown in that country. So they faced some difficulties because of the changing climate, um, and that's basically an arid area. So it's a very dry area to Uzbekistan where you get, 100 millimeters precipitation for the full year. And they still work on agriculture. And they wanted to look at the temperature changes, the impact of these temperature changes into the root zone of the soil layer. So, can we forecast that? So it was a very novel book, and we had a discussion, and I thought, why not to try that? So you may think that this is not really an engineering problem. When it comes to civil or electrical, mechanical engineering problem, it's something, not really focused on hardcore engineering. But we talk about this one, and we saw we we gave our inputs to overcome this practical issue. They were seeking a solution, and so we worked together and we were able to publish that particular work in Nature Scientific Reports. And this is the first ever work along the lines from the world to forecast the soil temperature, which is under 10 centimeters below the surface. So you can access the paper freely from the given DOI. So what we tried was we used the atmospheric data which are available. Now you can see that air temperature is there, relative humidity is there, and wind speed. Now, surprisingly, you may notice that we don't have any rainfall here. Why? Because, as I told you, it's very insignificant. It's less than 100, millimeters for the whole year. So it doesn't give any impact to the soil temperatures at about 10 centimeters level. So, which we found again from our work. And we formulated these mathematical equations using artificial intelligence, and we were able to predict and forecast predict and forecast the soil temperature levels at 10 centimeters. So and you can see the outcome of that. It's think it was published in last year, if I can correctly. Maybe 6 months, 6 to 7 months ago. By now, it has reached as one of the most read papers in Nature Scientific Reports. And after this, several people came to us and asking whether we can help with them with their agricultural issues and so on, which we are working on at the moment. Now, these several people includes countries like Ethiopia and some other, countries in Southeast Asia. Okay, now before we start the things, I told you that I'm going to talk about a couple of my experiences about putting a problem. I would rather go from a, a, an engineering problem into research work. So let me start the work with that. Hope you found some interesting stories about putting an engineering problem into research from these two or the couple of examples. So, first, I'm not an expert on this. Okay, I need to tell you that I'm not an expert of putting the research or doing research in the world. So there are loads of people who are well above me and so on. Now, this is not the universal method. So, I'm not going to talk about a universal method today, but my own way, which worked for me and still works good for me. So, I'm going to present a working methodology uh, to me, and it worked really well for me. So, hopefully, I can give you some insights and so that you can move on. Yeah. So we can identify two major types of research work in the world. So the first one is you are doing a research work for a postgraduate or seeking a postgraduate qualification. For example, a PhD, MPhils, Masters of Research, and so on. So basically, if you look at that, it's an individual effort. So when you are working for a PhD project, yes, you have a supervisor or set of supervisors, but at the end of the day, it's an individual effort from the candidate, him or herself. So the second one is for consultancy or publishing an index journal paper. So you can do research work for consultancy or publishing just as for your interest in index journal papers. Remember the couple of case studies or couple of research work that I have showcased you earlier. So they were not for any consultancy. I basically worked on these two problems as I was just interested about the problems. So, and at the end of the day, we published an index journal paper from one of these, these studies. So basically, it's a team effort. So when you work for a research project in consultancy or working on an index journal papers, as you can see from my previous studies, I'll go back probably. Yeah, so you can see it's a set of people who work together to get something out of this problem. Okay. So what I'm going to talk you today is the latter part of this research. So I'm not going to talk about the research work about obtaining for a postgraduate qualification because it's another talk or it's another different aspect. So let me process. So assuming that we have a particular problem as engineers, we know that we are very good at assuming this and that and so on when it comes to our work. So let us assume we have a particular problem to develop. So that means we know the research gap or we know the gap, what we have to do. So if not, we need to find a research gap. We need to find the research gap. That's going to be another big detailed topic to discuss, which I'm not going to do it today, but I'm happy to guide if anyone needs some information. So we are assuming we have a particular problem to develop. So first and the most important. So this is our first step. You have to read the problem. Read the problem properly. Second, again read the problem and understand it. So that's another important aspect of this. So the third is again read the problem. So you have to read the problem, understand it, but with physical meaning. This is very important when it comes to formulating an engineering problem into research work. So, understanding the problem and putting it into the physical meaning is very important. So, once you do that, you can reverse this particular step. So you can reverse the third step. That means you have a physical scenario. For example, the river meandering and Daduru Oya basin. So you have the physical scenario. Then you can understand it with your engineering essence. So that's the first and most important aspect of putting an engineering problem into research. Okay, once you do that, you need to find background information. This is very important again because when you look at the problems that we deal in this world, Um, as I said you again, you can't segregate a problem stating that it's truly an engineering problem. You have loads of different variations here and there, and you have to take the a help from various people in various disciplines and so on. So, how would I find the background information? Now, this is what I basically do. If I find a problem, I read the newspapers. I usually read the daily newspapers to understand the things. So I catch a lot of background information from these newspapers. I'm not saying that they are 100% genuine and authentic, but I can get some, background information from newspapers. Listen to news. So I used to listen to news to gather some data. For example, what are the problems that we are facing based on that? Say, if we have a problem of flooding, we may see, as engineers, we may see from engineering eye, but that's not important for the generic public. They know nothing about these a flood analysis, frequency analysis, intensity frequency curves. They know nothing about that, but they have different set of views about floods and so on. So when you talk, when you listen to news and when you read the newspapers, you can gather their views. So that's very important. And you have to observe the environment rather than, when you are traveling. For example, if I go to my first case study, just like the kids nowadays, if I were traveling with my handphone and putting like this and texting, I wouldn't capture the environment. So since I captured the environment, I thought of working on the Dadroya meandering problem. So you have to observe the environment. That's very important. Again, when you are putting this problem into research work, and you have to talk with peers. Definitely, as I said, it's not one man show. It was like that, say around 50 years ago, and so on. It is not going to be a one man show now, and you have thousands of examples from the research work which we have observed. Even if you take the example of the vaccination of COVID-19, you're talking about Pfizer, you're talking about Sinopharm, and so on, these vaccines. So it's not just a matter of getting the results from one set of group. You had various types of people working together in order to get the final outcome. So you definitely have to talk with peers. So that's what I exactly did when I look at the first and second problem. We were talking about this particular problem and trying to understand a set of solution. I repeat that, a set of solutions. It's not just a single solution, but a set of solutions. Then you had to talk with general public. So you had to get their idea as well. So this is these are several ways that I would find the background information. Then moving on, I need to justify the importance, why this is really important. See, when you are working on a research project, when you are putting a problem into research, I need to justify the importance. So, how would I do? I need to find who is affected and how. So, for example, farmers, municipalities, industries, various stakeholders are there. So, I need to justify the importance. As I told you, when you go to a medical doctor, you're not worried about his medical terms and so on, but you are worried about your problem. So you want to solve that. So that's the layman's word. So you're trying to identify the affected people and affected variations or how we are affected. So the stakeholder identification is very important in justifying the importance. Then what economic, social, environmental costs are involved. Now, you may recall these three catchy words: economic, social, and environmental. These are the three pillars of sustainability. If you look at United Nations sustainability goals, so you have 17 goals. The 17th one is the integration of the first 16 goals. So, we are working towards, no matter what profession we are, but we are working towards achieving these sustainable development goals, which are under these three pillars. Economic, we have to look at the economic justification, we have to look at the social justification, which we always forget when it comes to engineering problems. Then the environmental cost involved. So explain how solving it adds value or innovation. So that's where you have the research input. See, we have a problem, we are explaining how the solution of this particular problem would add a value or innovation to the problem. So that's the research bit which we are talking here today. For example, just an example, reliable water pumps are essential for crop yield, reducing manual labor and increasing food security. Now, when you look at countries like, even this would happen to Sri Lanka as well. If you look at the countries like Japan, they have a severe issue of population growth. So I'm basically against the population growth, but you have to manage it properly. Since Japan hasn't managed this population growth, they have various issues of finding the skill sets or the youth skill set to do various jobs. So they might thinking automation of these problems for the agricultural issues, which is a tricky thing to the world in increasing food security. So we have to justify the importance of the problem which we are looking at. What is the outcome of this project and how it would affect the stakeholders, and are we looking into sustainable development goals from our solution? Okay. After that, now this is a kind of a funny step which I'm doing when I'm formulating a problem into research. I'm sketching the problem. So, to tell you frankly, I was very bad in sketching when I was doing my bachelor's studies. But I'm not talking about sketching these, mechanical drawings and so on. I'm talking about sketching the problem into research. So, I would give you, a set of examples of my own work. So, I would explain these sketches. Now, when you look at this particular sketch, I wanted to look at, again, point options pen. So I was in a Samanlagava reservoir because they have a very nice environment for a survey camp. a residential survey camp, which you probably know in bachelor's programs in Sri Lanka. You are heading for a remote area to do some survey work. So I was in this Hamanlababa area, and I noticed that there is an issue of leaking. So I didn't want to look at the leaking problem, but I wanted to look at a different aspect. What would be the power generation? What would be the impact of power, these issues in power generation? So I wanted to look at, so and I wanted to look at the power, I'm sorry, power generation with respect to the rainfall. So I didn't want to look into the hydrological analysis of this case, but I wanted to look at in a different eye. So I use basically a um, machine learning aspect in achieving this, outcome or the goal. So I sketch at the catchment. I noticed that there are several rain gauges along the lines, and I could find the power generation. So I was just sketching. It's a rough sketch in order to find the power generation from the Saman level reservoir. So what I was doing at the end of the day, if I can get the rainfall to these rain gauges, I could tell the power generated from the Saman level reservoir. So that was my one of my goals. And having said that, once the model is ready, if I can get futuristic rainfalls, for example, we have various ways of looking at rainfall in another 20 years, another 50 years, another 100 years. You have models developed from various researchers in world. If I can get those data, I can feed them into my model, and I can tell the power generation in the next year, identifying the seasonal impacts and so on. So that's my starting point. I sketched that. So I wanted to look at the same scenarios with several other catchments, like the Navakaganga catchment. It's a mini hydropower, and a Ratna catchment, again a small hydropower catchment, where we didn't have any rain gauges inside that one, because this is a conserved area. You can't really have rain gauges in the catchment. But I was able to find several rain gauges, outside the catchment. And will I be able to use those, rainfall data away the catchment to predict and forecast the power generation in Eratna. So that was my goal in that. So I sketch it. I basically sketch those things. I was able to find these data, and basically you have to buy these data from various authorities. For example, if you want to get the rainfall data, you have to buy them, and so on. Fortunately, I was able to get the power generation data again from one of my own batchmates who works for this particular industry. So you can see that the networking is very important in these work. All right. So sketching the problem is very important to me. When I wanted to do that, I usually take a pencil or pen. I have my diary here. I just draw them, and I take this the figure or the capture, and I send share them using my research groups, like for example WhatsApp group and so on. So that's how I start the problem to see in research work. Then I need to define the constraints and the scope. As I told you, I can't do everything. I can't do everything, and so I need to define my scope with the constraints. So I'm listing my technical, economic, geographical boundaries. Sometimes you have various issues of using the technical stuff and some geographical boundaries and so on. I would like to take one of my own examples again here. I was working with one of the projects in again one of our neighboring countries. So we have a research group working on this particular neighboring country, and we presented the country map. And from the then when we presented that work into a journal, the journal came back to us saying that, okay, remove this particular figure because there are some issues. There are some ongoing issues going on in a couple of countries based regarding the boundary of these countries. So we had to remove those maps from our work. So that's a tedious issue which we are to deal with geographical boundaries and so on. Actually, this is a couple of neighboring countries to Sri Lanka. Um, yeah. So I need to define the constraints to look into the scope. Then understand what my skills are. As I told you, I'm not the expert in everything. Having said that, we worked for several healthcare research work which are highly impacted to the society. So I'm in a background of you know civil engineering, specialized in water resource management, but now into explainable artificial intelligence. But we worked very good research work into health analytics and so on. So I'm understanding my skill set. Then, if not enough, if I can't do that by myself, bring the skills, get a team to work on the problem. Now, this is why I said I'm not going to talk about a research formulation for a particular degree program or postgraduate program, because when you are doing your research work to a postgraduate program, you are on your own. Unfortunately, you are on your own. You can get some information from others, but you have to do that by yourself. So that's why we are talking about the teamwork aspect in this particular discussion. So if my skill set is not enough, bring some skills. For example, when we develop the soil temperature under 10 centimeters, the surface, I'm not an agriculturist, so I know nothing about those things. So the root zone or the seed germination, I know nothing about that. But that's very important. That was very important for our research work. So I had to bring those skill sets to the work. So getting a team is very important. As you know, many research problems are now multi or interdisciplinary. They are not single directed ones. You have to think about various aspects because even if you look at the United Nations Sustainable Development Goals, nothing is a specific. You have no specific goals. But if you look at one particular action, say a climate action. I can't really remember the numbers. Probably SDG 13, climate action. That's it. So climate action, how we can look in from engineering eye, agricultural eye, different aspects. So they are cross disciplinary actions. Okay, so we have to acknowledge the assumptions and limitations. That's very important when we develop a problem into research. As I told you, we can't do everything. So if I go back to my own experience in Dadroya, had we received enough data, the measurements and so on, if we had those things, we would have done a wonderful research work. But I understand that sometimes we can't get those information. Sometimes even the rainfall data, when you want to develop intensity, duration, frequency curves to Sri Lanka, because we were using 1989 curves even now. So I wanted to develop them. So I bought these data from the Department of Meteorology, spending around 2 million rupees. But if I wanted to do that in another country, you could have obtained those data free of charge. So we need to acknowledge the assumptions and the limitations when we do research. So next point is once we understand these constraints and scope, so we have the research sketch, we have understood the constraints and the scope, then I go into the generic or general literature review. So I talk about I wanted to understand the background of this particular project. Yes, I found several background information from various media, newspapers, and so on. They are not as I said, they are not the they you probably get some false information from these media and so on, because anyone can write anything into the newspapers and so on nowadays. So I would do the general literature review. Google Scholar is a better approach. Okay, we have different other approaches like Scopus search and so on, but Google Scholar is everyone knows about that. So so I basically select the time frame when it comes to research. Say you can select the time frame to the last 5 years, because research is dynamic, every day updating. Every day you can see the updates about research work. The methodologies are updated, the approaches are updated, and so on. So I basically go for last 5 years work. Then check what is known. I have to understand what is known about the problem, because sometimes we may not look into very novel problems in the research work. A case study one. So you probably can get some information from various other published papers. So take them and note them and understand the approaches. Cross check. So this is again important. When you understand the approaches, cross check with my skill set. Am I able to do this? So you have to cross check with your skill sets and cross check with my resources. Do I have enough resources for them? Okay, when you do the generic or general literature review, so you have some idea about the project or the problem, then you have to do a systematic literature review. Now, having said this systematic literature review, I'm not talking about the systematic literature review which is in healthcare related research work. It's a different way of looking at the SLR into health analysis. So what I mean by systematic literature review here is more focused literature review. So we did the general literature review. Now we are looking at the focused one. So it is well structured and rigorous research method that aims to identify, then evaluate and synthesize all relevant literature on a specific topic. So you are looking at a very specific topic on the literature, then to answer the clear research problem. So once you do the general literature review, I would go for more focused literature review. So I'm expanding my understanding about the problem. Remember the first and foremost important steps in putting a problem into research. Read the problem. So read the problem and understand it, and read the problem, understand it, and put into the physical words. So this is what you are doing. This is what you are doing. So you are putting your engineering essence to that. Okay. So our aim is known. Why? Because we are talking about a predefined problem. So when you define a predefined problem, your aim is already there. But aim and objective, which are always aligned together. Many people think that they are more or less the same, but they are different. So you have to set the research objectives. Now, our aim is known, then we are looking at setting out our research objectives. So, objectives are the specific steps you will take to achieve your aim. This is very important. Okay, so aim, as I told you, many people still think that aims and objectives are the same. No, they are different. Objectives are the specific steps you will take to achieve your aim. So the aim is what of the research. Okay, so the aim is what of the research, and the objective is the how. Hope you get some insights about aims and objectives. So research objectives are the goals to be achieved by conducting the research, and objectives should be logical and coherent. They should be feasible, realistic, considering the local conditions, and defined in operational terms that can be measured. See, objectives should be measured. So you have the aim, then you define the set of objectives. This is another important aspect when you formulate a problem into research work. Now, you have to develop a methodology. So you identify the set of objectives. Now you have to achieve that, achieve those objectives. So how would we achieve these objectives and get the final outcome? When you achieve those final outcome, you're in a climbing ladder. So you have defined the problem, you have defined the aim because you already know that, then you have identified the set of objectives. I would basically go back to my research sketch step. So I would go back to research sketch and revisit. Now, after this research sketch, I have done the constraint analysis, I have done the literature review. So I know basically what is known, and I have understood the approaches, and I checked my skill set, and I have done a focused literature review. I know my set of objectives to achieve. Now, taking everything into the basket, I would go to this particular step, develop a methodology, because this particular step is very important. If we are not defining this correctly, we are going to lost on our way. So we need to get a working methodology. That's very important. So revisiting my skills, revisit my technical support. Why? Because we need to ensure the feasibility of our work. Then we have to develop an executable methodology. Now, this would be probably easy for me to just tell, look at the research sketch and you have the objectives and develop an executable methodology and so on. It's very easy to tell, but I know you guys also understand it's very difficult aspect because you need a lot of time. You need to spend a lot of time in developing an executable methodology because you will notice that when you're working in teams and so on, you will have loads of ideas and loads of information, and you will notice that you can't really get into some results after doing that. So it's like changing the approaches in different ways and so on. So in that case, I would break down the methodology. I would break down the methodology into subsections. So rather than looking at the holistic view, I would look into different aspects of the methodology. So I would break down the methodology section into subsections. So when I'm doing this, I used to sketch this methodology because we can use, if you're publishing a paper based on this research work, you need to give you the flow chart of your methodology. It's very important. So when you sketch those things, it's easy for us to understand. It's easy for the readers to understand. So I'm breaking down the methodology into subsection. This is very important. You need to keep alternative ways because you will notice that sometimes you develop a very good executable methodology. You will notice in the halfway down, you can't do that because of various aspects. So again, without highlighting most of the details, we were working on a particular project to Sri Lanka, and uh, we heard from the relevant authorities that they would share the information, relevant data at a cost, at a cost. But we hired a research assistant, and we were working very nicely to that particular project. But suddenly, the relevant authorities said that they can't share the data. That can happen. So you need to find a different way to overcome these problems. Another story, I was working on on another project, and we had a research assistant working on, and suddenly he said, he's getting a PhD opportunity from the United States, and he need to go. So I can't ask him to wait and complete those things. So you need to find alternative ways of achieving the targets. This is again important. So when you have those things, execute the methodology with a clear focus. You need to identify the time boundaries and so on. You need to execute the methodology with a clear focus. And one of the very most important aspects of getting a problem into research work, you need to disseminate it. If not, no one knows about your work. If not, no one knows about your work. So you have to disseminate the outcome. So when you disseminate the outcome, it could be a conference paper, it could be a forum talk, it could be a journal paper, at least it could be a newspaper article. So share the outcome openly. Keep it in open access if you can, because it's very important. When it is in the research world, you don't bind the people, or you don't bound the people of reading the information. Give enough information to the people to read. So try to give them open access as much as possible. So Google Scholar page, ResearchGate page, LinkedIn page, there are few of them. You can disseminate your outcomes in various ways, various archives and so on. Okay, so what is needed? So this could be probably my last slide. So what is needed? So you have to have the curiosity. So a desire to explore and understand the phenomena deeply. Then you have to have the open mindedness. So it is the willingness to accept new ideas. Whether we like it or not, we need to accept the new ideas. And you can't see everything as a black box. You have to change your perspectives based on that. Now, I would again give you a very a good example for this. So, when I was starting to look into machine learning aspects, at that time we had artificial neural networks, and that was in 2016, 2017, and so on. And it was a black box model, so no one knows what is happening inside these black box models. So many people were in a disagreement to use these artificial neural networks or machine learning approaches. And many people still think that you have data set, you can apply machine learning and get the outcome. Now, with the advanced technologies like explainable machine learning, so you can define what is happening inside this black box model. So if you're not accepting the new ideas, you can't move on. So what is needed? So you need to accept the new ideas and change your perspective accordingly. It's a dynamic process. It's a dynamic process and so on. So the time management is very important. I'm not asking you to have a Gantt chart for everything, but you should be knowing that you should be knowing that the time management is very important. Suppose that you are working on a particular problem and trying to give some outcomes within couple of months. You need to keep that target. You need to arrange the time management if the desired outcome is due in 2 months, 3 months, and so on. Those who are working under me, we are defining these things properly before we start the problem. Supposing that, okay, we have this is our target, so we are working to that particular target in achieving. And the critical thinking is very important. So you are analyzing information logically and evaluating arguments carefully. Sometimes, you don't know the outcome of the research problems. So you need to accept the outcome. If the methodology is correct, you need to accept the outcome. Not only the outcome, that outcome has to be physically interpreted. As I told you, no one understand about these engineering outcomes and so on, other than engineers and so on. So to give that outcome to the general public, you need to interpret them in their language. So that's again our target. Finally, the attitude is very important. So your attitude of working on problems and building them into research is very important. Okay, that should be my last slide. But I wanted to go and summarize the things. I think I'm in the timeline. Yeah, almost 1 hour. So when you find a problem, observe it carefully. This is what I still do. During my career, somewhere around 18 years now after my graduation. So I'm basically looking at the problems again. It's as a new problem to me every day. So I'll take another example and explain this thing. So we were having a kind of it was a family trip to an underground cave um in Northern Ireland. We were visiting there. So we went to I think somewhere on 1.5 kilometers underground, and that was a cave. The name is Marble Arch Cave. So underground, you can observe these calcium carbonate, calcium bicarbonate structures, and so on. We had a guide. We had a guide, and he explained um, three small creeks, surface creeks or streams, comes into the underground and moving somewhere around 1.5 kilometers. They are underground rivers, okay, small rivers, and move uh, 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 a, somewhere around 1.5 kilometers and comes up again to make a river. So he was explaining that. So I thought that we have a problem there. We have an engineering problem there because we know that Ireland is facing significant threats because of the changing climate. The Irish name for Ireland is land of water or land of rain or it's land of wet. Now, over the last couple of weeks, we were experiencing a drier period. People really happy because we had sun and so on. It was very warm, 23 degrees Celsius. Everyone was happy about the weather, but I felt something is wrong in this pattern. So when we had this visit, I thought of working on that in hydrological point of view. Soon after the visit, I had a chat with this guide and asked, "Can I obtain the relevant information about this particular thing and so on?" So I had a detailed discussion. Then he was kind enough to guide me to the relevant person. I will show you a business card of that particular person. So this particular person is the scientific officer for that particular cave set. So I was able to catch him on site and had a very fruitful discussion. And he was able to tell me that the current work going on in the geological aspects, because many people were interested about the geology of underground caves and marble and so on, but he said no one has looked at hydrological aspects. So I thought that's a wonderful problem for me to put into research work. At the moment we are in the negotiation of putting these things, because the data are available from 1986 to now. It's very healthy data set, but obtaining the data is not really easy. We have to It's free of charge, but you have to go through some processes, the ethical clearances and so on for them. So we are in the process of negotiating that work. Now, look at this particular step or particular example. The problems are around you. You never know them unless you clearly observe them. You should have the curiosity for that. You have to have the open mindedness. So observe them and grasp them, then put your engineering essence to that to bring those problems into research work. Once you complete the research work, I'm sure you will get enough information from the future talks as well. So once you complete the research problems, please disseminate the outcome. That's very important. Then only people would know your work and the importance of that work. So that's very important. Okay, so that's a bit of summary of the discussion today. I'm happy to take any questions or comments from your side. So I have given you my contact details here. If you want to contact me, the first one is my official email, and the second one is my personal email and my Google Scholar access as well. So you have these data and so on. I would be happy to share my presentation as well. So if I can take your questions and so on, I'm happy to take them. You know, if I can guide you. Thank you so much.
Yes. Thank you very much, Dr. Upaka. And it was a really interesting and very informative presentation. And now it's a Q&A session, and the participants can raise hand, or otherwise that they can put their question into the chat box. Now I have seen several, and before coming to the questions, I think now there are many undergraduate students. Do you have anything to tell? Because I felt sometimes you have focused for the masters and the PhD level, but for undergraduates, do you have something to tell for their research I'm talking about?
Yeah, and so when you look at the undergraduate research work, um, I would say it's very advanced now, because Okay, to be frank with you, when I was doing my bachelor studies, that was in year 2005. 2005 we looked at the bachelor's research work, and it was more or less a group work which we had to do in undergraduate research at that time. And we were not really focusing on research at that time. We were more or less focusing on case studies and engineering problems. But luckily I found a research problem at that time. Now it's very critical. Why? Because it's another module. It's another module which you are working on while you are doing the other coursework and so on. For example, you probably have another 3 to 4 taught courses while you are working on this research work. Usually in Sri Lanka, I think it's 1 year project, which stands for making a research proposal and going into the final outcome or the dissemination of the research. But I know most of the universities in Sri Lanka now, they are targeting at least a conference paper from the undergraduate research work, which is very good, at the end of the day. But when you want to put a problem into the research in bachelor studies, um, this is the challenge which we are having. Now you are coming from theoretical background from your year one, year two, year three studies. You have various taught courses, core modules, technical electives, and so on. But suddenly you are dropped into final year research work, which I believe a bit of challenge to these students. Why? Because we come from exam mindsets to the research work, and most of the students, even I'm supervising several students in Sri Lanka, it's another module for them. It's not really a research work. So we have to come out from that mindset and think about the real research outcome of the work. So rather than a module, think about rather than getting 6 credits or 8 credits from your final year research project, think about it's a research approach. So your supervisor will definitely help. Why? Because our education, the education system which we practice in Sri Lanka is not project-based learning approach, uh, which I know I may be wrong. So the students are not the eye of looking at these problems in research work when they were working on several projects in year two, year three, and so on. So it's very important going back to your basics and talk with your supervisor, and not only with your supervisor, talk with others as well. So talk with various stakeholders, and do not limit your work for a couple of hours and so on. Take it as your project, because I noted this particular information even from my bachelor students who are in Sri Lanka at the moment. When they present their work, they tell my supervisor told me to do this, my supervisor asked me to do that, and so on. No, that's not correct. It's make it your own project. So think it as my own work. Yes, your supervisor will help, some others would help, but take it as my own work and perform to that. So then only you can get a very good outcome from the work. I know we have very wonderful outcomes from these bachelor's projects and so on. So again, you need to read a lot. Kids, those who are doing a bachelor studies, um, keep away your mobile phone for some time, probably. Uh, Look at the environment and understand what's going on. Read a lot. You need to read a lot. It may not be just the engineering things. You have to listen to political behavior of the country. You have to listen to the economic behavior of the country, because these are not really a single directed projects. They have different dimensions in various the aspects: economic, environmental, and social aspects. So you need to think about them as well. Then bring your problem and analyze it. Is that okay, Professor Bandhani?
Yes, Professor Fakir, that I liked your talk, especially that you asked them to be away from their mobile phones like Facebook and all, and also read a lot. That's the one that they don't do. So if they read a lot and if they are away from the mobile phones, I'm also very agree with you that of course they will find the problems and looking around their environments. That's what they don't do. Even when we are teaching, when we ask some simple questions, they don't. They most of them are unable to answer. Not all of, but there are good students also. And
Yeah, yeah, yeah.
thank
That's
you
very true.
so much. And especially the undergraduates that because nowadays we are. I think most of, especially in the open university, that we are formulating their research for undergraduates. So students are around and roaming around, and they are hanging that how to find the research, how they are formulating the research. So I think all other universities. I think there are so many questions in the chat box you can see, and very
Yeah,
interesting questions. Would you please
yeah, I'm going
help
through.
them to?
So, can anyone see the PPT? I think yes. Okay.
Yes.
Then I have question to present. How to distinguish delimitation versus scope? How to validate results when using freely available open and source data? Okay, the first thing. So the scope. It's very subjective one. When it comes to research work, depending on your limitations, depending on your criteria and so on, you need to define the scope. I know it's not very easy when you are a startup. Defining the scope is not easy at all when you are a startup. So you need to look at the limitations of the work. Okay, so you need to look at the limitations, constraints of the work. Then only you are defining the scope. So it's the eliminations and scope, they are interlined together. So you are trying to understand the constraint of your work and then define the scope. Because when it comes to, again, bachelor's final year research work, you have 2 semesters. You can't do wonders during these 2 semesters, because that's where you probably start to think about research work. So understanding that time boundary, okay, understanding that time limitation, you are selecting a portion of the a very big problem probably. So your supervisor will help definitely in that sense. Now, if I were to do that, this is what I would do. I'll think about a big problem, and I have subclusters about that big problem and give them into individuals. It's a win win situation, because when these students perform in these subclusters, at the end of the day, I can join them, I can merge them into the outcome of the big problem. But again, to the students, those who are working for 2 semesters, basically, 14 and 30 weeks and so on, or maybe less than that. Here it's just 12 weeks for a semester. So you are bound with time, and also you're working on other activities as well. You have this and that and so on. So in that case, you have to understand the constraints and identify the workable stuff for the timeline. So defining the scope is very important in that case, and talk with your supervisor again and again for that. Then the next one is how to validate the results when using freely available open source data. So that's very, again, tricky question, because, and very good one. I don't really know what is the cluster of open source data and so on. Sometimes, um, if I take the example as rainfall data or climate data, You can get climate model data from various cases like RCPs, SSPs, and so on. You can get various model data. So in Sri Lanka, you have 500 odd rain gauges, but uh, these model data you can get into coordinate wise. So the validating these things are very important because we know nothing about these models. Sometimes they may not be the best. So bias correction is always important. So how to validate results? That's very subjective because you have to get some observed or physical data or results to validate. Having said that, I totally understand the difficulties of getting these, physical data and so on. Looking back to my own problem, the first problem which I showcased, the Landsats and so on. At that time, I didn't have enough, I would say, funds to get LiDAR data. So I used the Landsat data, and I know that there is an issue with Landsat data because it has an error. So to validate them, I couldn't really get the physical one because we don't have any. But at the same time, I was able to go physically into these bends, some of those bends, not all the bends, and understand the behavior. So that's again a way of validating with the limited resources and so on. So if you want to specifically talk about specific data, then I would be able to probably give a definite answer. Okay, the next one is undergraduate from University of Morocco. I'm doing follow. Okay, systematic review. Now, when it comes to systematic literature review, it's again a very big topic. When it comes to healthcare, you probably go into the detailed Scopus website, different websites and you to libraries and so on. So it's a very detailed topic. But but when you look at the systematic review for most of the other engineering problems and so on, you can go to into the Google Scholar or Scopus website if it is available. I'm not too sure if it is available. So you can screen down the papers which were published. But again, using Google Scholar, you can get any paper. If you search Google Scholar, you will get journal papers published in reputed journals, index journals, and also some false information as well. So you need to be very careful of selecting these journal papers. So what I would basically do, as if I were a startup, so I would basically go into the Google Scholar and find the research papers, but I would look into the journal particularly. If that journal is an index journal, then I would probably buy the things which is told in that research paper. If it is a fake journal, there are various methods of identifying these fake journals and so on. Then I would not uh, go and refer them in my study. Okay, the next one is agricultural faculty. I would like to kindly ask how I can conduct research using secondary data, including key steps in one. Okay, another detailed explanation is needed for this one. I think it's a very long one. So you can do research work using primary data and secondary data. Yes, sometimes you are the person who is collecting these data as the primary source. Sometimes you are using someone else data to your research work. That is possible. But when you use secondary data, depending on the context, you need to get the approval of these data. Now, for example, I'm using rainfall data from for Sri Lanka for some of my research work. I need to state that these are collected from and measured in the Department of Meteorology, even though I pay for them. Okay, I might think that I'm paying. Why can't I use them as they are? No, it's not the way. When you work on research, I need to tell that these are the data which collected from this particular legal authority. That's very important when it comes to secondary data and so on. You need to tell the give the enough information for the readership and so on. So then basically you need to sometimes get the ethical clearance as well. Now, even for primary data, we are not really into those things much. But when you go for interviews and so on, if you are doing interviews, you need to get the ethical clearance. If you are raising questions from public, you need to get the ethical clearance. I know it's a tedious process, but that is very important. Then when you have them, you can process further research work. Okay. Um, how do we ensure that we capture all existing research about a topic? Okay, now this is very important. Is going back 5 years really enough? That's another good example of this research work. The issues faced in the research work. Okay, I told you we can't do everything in the world by one go. So why I'm using 5 years time boundary? It's not a definite 5 years, okay? Because it's a dynamic world. Depending on the context, you need to think about the past work. So if you search, if you basically search them in the Google Scholar, if your keywords are perfect or at least acceptable, you would get most of the published papers. That's for sure. But sometimes there are some issues. Why? When you click into subscription type journal papers, you may not be able to access them. So you don't probably know what is written in those subscriptive type journal papers. So in that case, we may not know what is written there. That's an issue. So 5 years is not an a line of boundary, but as a guidance, I use 5 years. But it doesn't mean that I'm not going to 10 years and so on. For example, I'll give you a very good example. I was even recently working on rainfall trends. So rainfall trends in a particular country, that's in Fiji Island. So we were working on a particular project on that. Um, so we use Mann-Kendall equation, which were published in 1953. Imagine we still use that non-parametric test to to look at the rainfall trends in the world. Yes, we have very sophisticated ways of looking at rainfall trends using wavelets and so on, but we still use 1953 published paper by Mankindle. So it's not 5 years. See, it's basically depending on the context. But during the last 5 years, whether we like it or not, the world is moving so fastly. It's very dynamic. So you will get thousands of new work during that time, which is updating. So I believe, as a guidance, going to 5 years is important and understand what is the state of the art. But it doesn't mean that you can't go beyond 5 years. You obviously can go and see what is written there. Now, capturing everything, definitely you can't capture everything unless you are into a PhD or like that. If you are in a PhD, yes, you can do a very detailed systematic literature review and you can capture most of the things. I know one particular person who is into PhD, and I think she has screened uh, more than 19,000 journal papers. Okay, see, the number is 19,000 journal papers to screen up to, I think, 60 or 70 journal papers. It took 6 months to screen out. There are some methods of doing that. Okay, so you can't do everything, as I said. Um, that's all I can see, I think. Okay, can gray literature be cited by? Okay, what do you mean by gray literature? Can you give me a detailed view about gray literature, because it's very depending on the context, you can define it in different ways. So, if I understood it correctly, citable in professional research work, without talking about gray literature, if it is published in a journal paper, index journal paper, I would accept it. But having said that, as I told you, it's a dynamic world. What we say today can be wrong in another couple of years' time, which you have seen, which you have obviously seen. See, what was published in a couple of years ago is totally wrong now. You probably heard about several news and so on, news articles regarding food science. So what we thought in 2 years is wrong now. So you have thousands of examples like that. But for the time being, I would accept. Now, again, that's why I kind of have a guidance of 5 years' time. So research is updating. So, okay, undergraduate from University of Luna, I'm doing my research on hydrological engineering to predict stream flow using machine learning. Okay, vector and physically based modeling, HMS, and evaluate the physical transfer. Okay, this is another important work which you probably can read my several papers, because we have done these things a lot. And if you want, I believe most of my papers are open access, so you can access them. So if you have any specific problem, if you have anything to discuss, I'm happy to discuss them with you. The student who is doing hydrological analysis to predict stream flows. What I would give you as a suggestion: draw your catchment. This is very important. Draw your catchment and understand the hydrological cycle inside the catchment. Okay? Draw the catchment and understand the hydrological cycle inside this catchment. That is a very good starting point of developing the data driven models like machine learning, then HMS, or like physical based modeling. Next, rather than going into machine learning, I would suggest you to look into explainability of that, because uh, it's a world that uh, going forward with explainability rather than the black box. So think about explainability of your machine learning model. Okay. Aim of the research, a summary of research objectives. No. Aim is what of your research. Objectives are how of your research. So it's not a summary. It's not a summary. Aim is driven from your research gap. Okay? Or what you want to do. Aim is what you want to do. What you want to achieve as a holistic way. But how objectives are how you gonna achieve. They are measurable. In engineering, specifically, you can function them. Okay, objectives can be mathematically function, so they are not the same. When you achieve these objectives, naturally your aim is achieved. So aim is what of your research, objectives are how of your research. That's all I can see at the moment, Prasabandhuni. I think
Okay, thank you. And I see you have clearly explained about what is the aim and also how you have formulate objectives in this within this discussion. And we will share this. I hope that ISL can share this presentation with the participants who have
yep,
joined today. And then you can see what once again that what is aim and what is objective. I think most of the students, when they are formulating their aim and objectives, are really struggling and they don't know. Sometimes they are just telling about the methodology as the objective. So that's also another thing what they are mixing up.
yeah,
Prosupaka, anything that you can say about it? If you can go back to that particular slide also, that would be
yep,
much
yep, yep, yep.
appreciated. And
Okay, so it's here. Now, in our case, in this particular one, aim is known. Why I say aim is known? Because it's a research gap. We have a research problem. We have a problem to develop. So we basically know the gap which we have to fulfill. That's our aim. So basically, we are trying to fill that gap, and that's our aim. See what of your research, but how we are going to fulfill this research gap. That's the those are the objectives. So I'll go here. Yeah. Objectives are specific steps you will take to achieve your aim. So the aim is what of the research and the objectives are how. And these are the important attributes. Research objectives are the goals to be achieved by conducting the research, and they should be logical and coherent, okay, feasible, realistic into local conditions, defined in operational terms. When you define your objectives, you have even action verbs. So I haven't written them. You have set of action verbs. For example, you can't simply say, when it comes to engineering research, you can't simply say non-measurable action verbs to develop research objectives. You have to have measurable action verbs and to develop these objectives. When you develop these measurable objectives, you can develop the relevant methodology for that. See, they should be measurable. You can't simply say unmeasurable things. For example, differentiate A and B. That's not an objective, because differentiate, the word differentiate is not measurable. You need to tell the measurable way of doing, analyze, and so on. You have to have the proper action verbs in define the objectives and so on. I think I have another couple of questions. I'm seeing them. Uh, do you see difference in research approach in science versus engineering disciplines? Okay, when it comes to research world, I don't think you have science and engineering disciplines at all. You had those things. This is my belief. You had them maybe 50 years ago, not anymore. It's everything together now. You have multidisciplinary actions. So you have science, engineering, even social science. That's another important aspect. I hope you can see these. Most of the research work now are aligned with sustainable development goals, United Nations sustainable development goals. So in those, in achieving these sustainable development goals, you have science, you have engineering, you have social science, you have the various aspects. Now, I would give you one of the examples. Health-related research is now related to music and so on. So you are talking about music in healing some health-related issues. So you have everything in that. You have science, you have engineering. Okay, how come engineering is there in music? It's mathematics. It's basically mathematics. You can take engineering solutions to that, and you have health and so on. So you can't differentiate these research work and so on. But again, when it comes to the subjective things like health related, when you do systematic literature, it's different. It's a bit different compared to the other aspects. And when you want to develop some health related stuff, you probably have to get the ethical approval, which is a very rigorous one compared to engineering work. Okay, when you want to go to a survey type research work in engineering, for example, traffic survey and so on, when you are interviewing people, you are you still have to get the ethical approval. Okay, you still have to get the ethical approval, but it is not detailed as an ethical approach which you are following with patients and so on. So these are the differences, but more or less you have multidisciplinary actions. So another question is a master student in environment science and rescue trying to get a grant for my research work. Okay, research grants. Coral mapping of Sri Lanka. Very interesting one. I really don't know how we are going to do the mapping, but we are now working on a particular project with Indonesian Aerospace Division to do something similar. So getting a grant. Um, um, there was a grant in NSF, as I know, and I'm involved in one of them. Um, but I know it's slightly difficult to get grants in Sri Lanka. Uh, but you still have, for example, when I was starting, I didn't have any money with me. Sometimes I spend my own money. Probably those who know me, a they know that I spend a lot from my pocket to do research. But again, having said that, getting a grant is very important. But I believe you have several grants from different sources. I can give you some ideas. NRC is one of the approaches. NSF is another approach in Sri Lanka. Okay, I know they are very limited and again very competitive, but you have other sources. For example, you can go into there was a grant from Indo Sri Lanka Research Grant. Okay, there was a very good grant, Indo Sri Lanka Research Grant, which I'm involved as well. So we put a proposal to that. So um, and also you have Erasmus grants. Again, we put another proposal with Sri Lanka. So Erasmus grants are there. Then you have DAD grants, um, which are from again European Union, but from more or less from Germany. And also another grant body would be looking into some international grants like Japanese grants and so on. There are some other grant bodies. Um,
Yeah, adding to that, Professor Upaka and the student who is from the environmental science, the IUCN, nowadays they are doing research on corals. And I
okay.
think in Sri Lankan IUCN, you just go and talk to them. They are a person called Dr. Shamil Vidanake. And so IUCN nowadays granting many for coral reef things. So they have a big project with coral reefs. I think that you can go and talk to them and see to see that the how the possibility of grants available. Don't be late. I think next week go and talk to them.
Yeah, and also I believe there is a very big project in Australia. If you can get access, they allocated 1 billion Australian dollars for the Big Barrier Coral Reef. So 1 billion Australian dollars, and they said they are going to hire at least 100 PhD students from that grant.
Very interesting. So the people who are with the coral reefs and also with the coastal tribes, they can see the access and reach to that 100
Yeah, because
PhDs. Yeah.
I think one of our PhD students here, he was working to me. Now he's doing his PhD in our university. I heard that he's going to use underwater robots to mapping the coral reef. If needs, I can get a connection to him as well. Yeah, please contact me. He is one of my very good former students. Yeah, I think Prabodha is here. Prabodha, I will probably drop you a message. Prabodha is a very good friend of mine. He sent me a direct message as well. Then I think I have how philosophical perspective matter in professional engineering research when working with multidisciplinary system. Okay, um, it's not a party table. When you're working in a team, it's not a party time. You have various ideas, which I honor, which I obviously honor them, and you try to keep the round table concept. You're not the boss, you're one of them, but it doesn't mean that your idea is not valid. Your ideas are always valid when you work in a team, but again, you try to back your your ideas with justification. You have to have some solid background or solid justifications. Even if you are a startup, you value the your ideas, then you try to back up those things. So working in with a multidisciplinary research team is not easy at all, because you have different backgrounds, different knowledge levels, and so on. So it's not easy, but again, you have to be a very good listener. I repeat that word. You have to be a very good listener. When you listen to the others, you learn a lot. Trust me, I still learn from my bachelor students here. I still learn from them a lot. We had to go for a field visit to measure some flow, a river flow. It's very easy in Sri Lanka. Okay, you just go and measure using current meters or whatever the things. But doing that here in Ireland is not an easy at all. You have to get thousands of approvals from this and that and so on. Then you have to tell that you have to take the responsibility. You have to put an insurance to go and cover your vehicles, cover your instruments, cover the people, students who are going. So that's a very tedious process. So, but again, I had several students to one of the creeks, and we measured the flow, and I learned a lot from them. Okay, yeah, I think that's all I have. Yeah.
Yes. No more questions. Yes. Thank you very much, Dr. Fuka, for your very encouraging as well as informative. I told you earlier, and so it's very important to our students that how to get into a research. So in coming days, coming weeks, that you will meet other people who are talking about how to do a comprehensive literature review, as well as that I'd like this Professor Upaka said about the how to find a research gap. I think that's also very important to students, as well as for some other topics. I am going to catch you, Professor Upaka, in future. And for today, actually, thank you so much. You spent nearly 2 hours with us, and it's very important, and it's very interesting presentation. And even that waking up at early morning that you join with us today now, maybe around 6 a.m. probably for our just around
Yeah, I'm
5:30.
very bad at that. I need to tell that. I'm very bad at waking up in the early morning because I used to work until 12 o'clock or 1 o'clock in the morning, and I usually wake up at eight
Yes.
8 o'clock in the morning. But I love to be there because this is what we are. We need to help others. We need and I learned a lot from this session. I need to appreciate that as well. So we if we can help people, that's what our life is. Because
Yes.
it's very even though it's 4:30 a.m. when I join the meeting today, but that's a very fruitful one because I felt it's very interesting and so on. Yeah.